In this video we're going to look at the theory involved for exercise 6c, reciprocal trig functions. So in the exam you'll usually get two types of questions. You'll either get the proof type of questions or questions where you need to solve to work out what theta is. So we're going to go through those two types of three examples here and we'll work through them in stages. So the first tip is to make sure when you're proving to get everything in terms of sine and cos, and remember that cot theta equals cos over sine theta, and if we want to get everything in terms of sine or cos, then we would use this rather than cot is a reciprocal of tan, so 1 over tan x. The other thing you need to remember is wherever you have an algebraic fraction being added or subtracted, so whether it's a over b plus c over d or a over b plus c, make them into one fraction. Okay, so wherever you've got an addition or subtraction, do that function and make them into one fraction and work from there. So we're going to look at the first example where we've been asked to simplify sine theta, cot theta, sec theta. So as I said before, we are going to first of all try and get this all written in terms of sine and cos. So we know that cot theta, and you must write everything down, cot theta is 1 over tan theta. And we also know that it's cos theta over sine theta. So therefore, if we take A, if we were asked to simplify sine theta, cot theta, sec theta, then that becomes sine theta. Cot theta is cos theta over sine theta. And sec theta is 1 over cos theta. So we can cancel out here quite nicely. So the cos thetas will cancel out, the sine thetas will cancel out, and my answer is just going to be 1. In the second example, I've been asked to simplify sine theta, cos theta, bracket, sec theta plus cosec theta. So intuitively I would think, okay, I'm going to rewrite my sec and cosec as a reciprocal function. So that will give me sine theta, cos theta, 1 over cos theta plus 1 over sine theta. Make sure you get those the right way around. Expanding my brackets, that will give me my first fraction, sine theta cos theta over cos theta. And expanding the second term will give me sine theta cos theta over sine theta. I can cancel out my coses, cancel out my sines, and that will leave me with sine theta plus cos theta. And I can't do anything else with that, so that's my answer. Now this third part, C, is a proof question. So I'm going to, can't really do much with the right hand side, so the left hand side looks easier to deal with. So taking the left hand side, write out the question. That would be cot theta cosec theta over sec squared theta plus cosec squared theta. Well, cot theta is cos theta over sine theta, and cosec theta is 1 over sine theta. sec squared theta is 1 over cos squared theta. And cosec squared theta is 1 over sine squared theta. So simplifying the top, that will give me cos theta over sine squared theta. And then if I add the bottom, two fractions, I'll get sine squared theta plus cos squared theta over sine squared theta cos squared theta. That's worked out quite nicely. So taking this fraction here, that I will going to keep the cos theta sine squared theta in the numerator. And here, sine squared plus cos squared equals 1, so that becomes 1 over sine squared theta cos squared theta. Now if you think, I'm going to write this part out again, but you've got to remember we are dividing fractions here. Just let me sort this out. Okay, so that gives me cos theta over sine squared theta divided by 1 over sine squared theta cos squared theta. When we divide fractions, the first fraction stays the same, so we have cos squared theta over sine squared theta. Divide becomes a times, and then we change second fraction. So sine squared theta cos squared theta. That goes over 1. Now, because we're multiplying, we can cancel anything in the numerator with anything in the denominator. So that cancels out my sine squared theta. And then multiplying through will give me cos cubed theta. So therefore I have proved that my left hand side equals the right hand side. So here we're going to take the second one, so 1 plus cos x in one bracket, cosec x minus cot x in the second bracket. So expanding the brackets will give me cosec x minus cot x plus cos x cosec x minus cos x cot x. Okay, so this will give me, so cosec x is 1 over sine x. I'm going to leave my cot x as cot x. Cos x and cosec x is 1 over sine x minus cos x times cot x, so that's going to be cos squared x over sine x. So here I can see that this part here is going to become cos x over sine x, which is cot x, and minus cot x plus cot x cancels each other out. So what we are left with is 1 over sine x minus cos squared x over sine x. And this will give me 1 minus cos squared x over sine x. 1 minus cos squared x is sine squared x over sine x. And cancelling down will leave me with sine x. Therefore, left-hand side equals right-hand side. Now, in the last few questions, we've been looking at proofy type questions. So here are some examples of our solvey questions. So if you look at the first one, we're looking at solving these for theta in the range of between 0 and 360. So if we take sec theta, so the first one we have sec theta is equal to minus 2.5. Sec theta is 1 over cos theta. And say that equals minus 5 over 2 as a fraction. So if we reciprocate both sides, that will give us cos theta equals minus 2 over 5. Now you've got to think of your quadrants here. So we're looking at theta, we're looking in degrees. Cos is negative, so we're looking at angles, or obtuse angles and a reflex angle. So we're looking in our sine quadrant and our tan quadrant. That's where cos theta is negative. So doing these, working everything out in the normal way, we will get theta is equal to 113.6 and 246.5 degrees. Always check whether you're working in degrees or radians. It tells us here that the range is in degrees. So for the second one, B, in B, we're given that cot 2 theta is equal to 0.6. So we've got a change of range here. So we know that theta lies between 0 and 360. So therefore we're looking for our range, our angles of theta, between 0 and 720 degrees. Remember to change your range. Right, so cot theta is 1 over tan 2 theta, and that equals 0.6, 6 over 10 or 3/5. So reciprocating both sides will give me tan theta, or 2 theta, equals 5 over 3. So therefore, our angles for 2 theta will be, our acute angle is 59 degrees. So tan theta here is positive, so we're looking in our all, so an acute angle, and we're looking in the tan quadrant, our two quadrants. So we have 59 degrees, 239 degrees, 419 degrees, and 599 degrees. Dividing them all by 2 will give me my answer, so that will give us 29.5, 120 degrees, to 3 significant figures, 210 degrees, to 3 significant figures, and 300 degrees. And they're all to 3 significant figures. Now our last question here, solve cot theta equals 0 in the interval where theta is greater or equal to 0 but less than or equal to 2 pi. So we're working in radians here. So let's write down cot theta is equal to 0. So that means 1 over tan theta equals 0, or tan theta equals 1 over 0, which is undefined. You can't have that. So that means, therefore, that tan theta tends towards infinity. So where does tan theta tend towards infinity? This is where you need to know your graph. So our graphs here, it tends towards infinity at the asymptotes. So that means our values for theta are where our asymptotes are, our equations for the asymptote. So that will be pi over 2 and 3 pi over 2 in the given range. So this is where your understanding of the graphs really does come into play, and you do need to be confident with them. Now our final example here is going to be a solving question. So this time we've been asked to solve theta between 0 and 360, so we're working in degrees, and we're looking at cosec 3 theta equals 2. So let me write that down. So we have cosec 3 theta equals 2. We're looking at theta in the range between 0 and 360. But we've got 3 theta here, so we've got to change our range. So 3 theta is going to lie between 0 and 1080 degrees. Okay, so cosec 3 theta is 1 over sine 3 theta equals 2. Reciprocating both sides will give me sine 3 theta equals a half. So we're looking in the quadrants where sine theta is positive. So in those quadrants there, and our acute angle is 30 degrees. So our first two angles for 3 theta are going to be 30 degrees and 150 degrees. Going around 3 times, then we'll have 390. So just adding 360 degrees each time, 510 degrees, and our last two angles, 750 and 870 degrees. Dividing through all by 3 will give us 10 degrees, 50 degrees, 130 degrees, 170 degrees, 250, and finally 290. And there we go. We've solved that equation. Now, all the work we've done here for exercise 6C is no different than what you've done in year 1 part of the course. All the same principles. Look at your ranges. Do you need to change the range when you're solving? Look in the right quadrants, write everything down. When you're proving, look at which side you're going to deal with, which one would be easier to simplify. It's usually the side with more information there, and just work through things methodically. Think about everything. And if you find with the proof questions that you're going on for hours, start again. It'll be a lot quicker. You probably made a silly mistake and you're going off in the wrong direction. I hope that all makes sense. Any questions, just ask. Otherwise, as it says on the next slide, I would like you to do all the questions in exercise 6C. The more you do, the better.